welcome to my talk. Let's drop right into the terminal. If you type in who I am, as kindly introduced me, my name is Noam. And the mouse is not working. Okay, yes it is. And I've been programming for almost half of my life now, which is quite a long time, a bit depressing if you think about it, but I've had a lot of fun, so everything is A-okay. I work for an amazing company named Healthy.io, where we take a smartphone and turn it into a medical device. And just plugging in here, I'm looking for excellent developers just like you, so if you want a job with a great company, come and speak to me afterwards. If you're interested in crazy tweets and stupid code, this is my Twitter and GitHub as well, so check it out, follow me. So let's get down to business. But the most important business beforehand is, if you love podcasts, me and my friends, including Yoav, we record a podcast in Hebrew, tech-related, called Cafe Bots. Look it up in any podcast-related application you like to use, or iTunes or whatever. We have a great time recording that podcast, and we hope you'll enjoy it as well if you choose to try it. So how many of you here use Groovy on a daily basis? Oh, okay, so that means I'm the conference weird guy. That's okay, it's fine. And how many of you use Jenkins? Better. How many use Elasticsearch? Great. And what about Gradle? Also good numbers. So it's great because it means I'm not the only one using Groovy, you're using Groovy as well, which makes me, again, the not weird guy. So, you know, oh Camel fanboys, eat it. Sorry. So, if you're not so familiar with Groovy, it's a very nice language. I like it a lot. It started out around 2003 as a hobby project. It's a language over the JVM, just like Scala, just like Clojure. And it's a bit of a weird sort of creature. It's weird because it's both typed and untyped. It's both imperative and object-oriented, but has very strong functional facilities. So it's kind of in between, sort of amphibious language, if you will, right in there. They were adopted by Apache as well, so they're well-based. They have nice money and a lot of standards and protocols to follow. But most importantly, it's a language which has an amazing community. It really is. It's one of my favorite languages. And the community is helpful and friendly and very passionate about what they do, which I think is something which is very important behind any language which you happen to use. Now, if I say the word groovy, and if I say the word functional in the same sentence, most of you are probably Googling this. This is a real WikiHow page, how to take care of a drunk person. Now, I assure you I'm not drunk, okay? But I do remind you, do not provoke or anger me. Well, you can, but I'm not a violent person, so it's okay. But Groovy truly is a functional language, or at least enables functional facilities, and I'll soon show you why. But for now, just so we don't bumble around the terminal anymore, I won't write, find name Groovy grep function all over again. Let's just create an alias for functional Groovy and call it FG. And before we go into the actual functional facilities, a few of my examples show some methods over collections. So if you're not familiar with Groovy, just a small primer where if you take, for example, a list, if you take a list, you can call the collect method on the list to perform a transformation, okay? Meaning if I have a list of numbers, I want to transform it into something else and return a list, I simply call collect with a method like Clojure or whatever, and I get the transformed list. I have also very nice methods such as sum to call in a list, which return the total of the numbers respectively. So this is just a very short guide to some of the examples you'll be seeing here. Now, one of the most important and basic building blocks of functional languages, for me, is the closure. Arguable, yes, is it truly functional? Yes, no, not for the scope. but it is important when you program functionally. And Groovy has very nice closures. By the way, this is Jackie Chan from Jumping Master. He'll be helping me out with definitions and technical terms and stuff like that. So, say for example, I'm a bartender, okay? We're in this nice and hot Israeli summer and we're all really enjoying it. But why don't we whip up a few cold drinks, such as a nice cold margarita, okay? And how the margarita works, very simple. It has 3 ingredients, okay? It has a triple sec, it has lime juice, it has tequila. Mix it up, add some ice. You know, if you fancy, you garnish it somehow with salt, and you're done. You have a nice cold drink. How do we show it in Groovy? Well, here you can see I've taken exactly the same thing I've just explained. I have 3 ingredients. I've declared tequila, triple sec, and lime juice. They're all closures. How do I know they're closures? Well, this is the closure syntax of Groovy. I have the parentheses, it accepts a parameter, 0 or more, and it performs some sort of operation, where the last operation performed in the closure is the one that's the return value. So I have 3 different ingredients to my margarita, and I declare a new margarita closure with the 3 different ingredients. I take all the ingredients, and I give it a certain parameter, which is my measurement. So if you look at the definition of the closure again, it's a method, normally first class or anonymous, whatever you choose, but it has the ability to capture variables which were declared outside of the scope of the closure itself, but within where the closure was declared. Meaning, the closure was declared in the same scope as measurement, so the closure can use the measurement variable. But you can also give it parameters. You can give it x, which is 1.5. So what happens if I call collect and join on the 3 different ingredients of the margarita? Well, I get margarita, 1.5 ounces of tequila, triple sec, and lime juice. Very nice, very basic. When I refer to curry here, it's not the food, even though we had a nice lunch, it's not food. Let's take again the bartender example. What happens if you really love the margarita I served you, but now you want 2 more because you're an uncontrollable alcoholic? Very easy as well. But why do I connect it to currying? If you think about how you make more than one of the same cocktail, you don't take a glass and then create a margarita and pour it, and then take another glass and then take another margarita and pour it, right? You take a bunch of glasses, like 5 glasses. You create a very large mixture, you know, make a huge tank of margaritas, then you pour them into the glasses, right? This is basically what, well, it's not, but that's the analogy I've made to currying. What we can do with currying in Groovy and in margaritas is provide functions which take multiple parameters but in different sets of invocations. Meaning, if I have a closure of a prepared cocktail, and it takes 2 parameters, glasses and cocktail. First, I can give it 2 glasses, only then I prepare the cocktail. And this is done and can be done on every type of closure, because in the end the closure is an object in Groovy, so every closure you can call on curry. Curry meaning provide the first parameter, which is glasses, move on. 1 invocation, which is a cocktail recipe, move on, and so on until you get the last parameter, and eventually, well, we get our recipe once again. But this time for 2 glasses. As you can see, the number of glasses I've given is the number of times I iterate on this closure to prepare. And I can also provide the index of the iteration. So you can see I printed out the glass number and the cocktail which I put in every glass. Now, it's also important to note that in Groovy we don't have only ordinary curry, we also have n-curry, which lets you invoke currying on a certain index. That is, if you don't want to call specifically the first parameter, but you want to call maybe the 3rd parameter, you can use n-curry and select the index. And you can also use r-curry, which is reverse. Same way, but you start from the end. Now, myself, as a seasoned bartender, okay, after I've made some margaritas in my life, I already remember how to prepare them. So I don't need to go back and look at the recipe over and over again, how they make a margarita. Oh, it's 1.5 of this, 1.5 of that, 1.5 of that. I already know it off by heart. Memorization, also available on Groovy closures, is also very nice. And if we take the same example from before of my preparation closure, the only thing I've added into here is dot memorize, also a function on every type of closure. Now, when we look at memorization, which is basically caching in memory of the method invocation, who can guess here what would be the output now? Before, I remind you, we had just this prepare cocktail invocation, and it printed out 2 glasses of margaritas. What happens now if I pour on this method twice? You there at the back.
It prints glass 3 colon margarita. And it only does it once though because it's memorized those 2 arguments.
Yes, that's correct. So we get exactly the same result as the former invocation. Why? Because we've memorized already this method call. The method call will not be called again, so I will not be printing out the glasses I prepared again. In-memory caching. Very nice. Now, if we take the example of the bartender, maybe I've had a very busy night, I'm working in a very popular bar, and I've also received a huge amount of very nice tips. I take the tip jar, I can calculate how much I've earned in the same night, but when you think about it, I'm a programmer, so I won't calculate it like an idiot, 1, 2, blah, I calculate it recursively. Now, I'm such a popular bartender that I've also earned so much money that if I calculate it recursively, I might end up Stack Overflow in my brain because I'm just, drowning in tip money or something. And we have tail recursion in Groovy as well, and it's a very nice, it's part of a very nice set of tools from the AST transformations library. So if any of you are not familiar with AST transformations, it's very shortly, it's a set of code that runs during one of the phases of the compiler. So you write Groovy code, then you can annotate it with a certain behavior, and that code will change during compilation. AST transformations being one of them is the tail recursive transformation. Tail recursive means first you do the calculation, then you recurse, and so you basically reduce your stack to a minimum amount. And what we can see in this example as well, as I've declared some cache method, where I have a list of all the cache I've been given, maybe it's $1 bill, $5 bill, whatever. And I've got the total cache which I want to calculate. It's a very simple recursion. We're not going to work out the math because I'm sure every one of you knows it. But the most important part here to notice is that the recursive invocation has to happen at the end of the method. But it's a very nice facility because it means it reduces your boilerplate code to something which you already know is going to happen. And it's going to be added only at compile time. And you don't really have to mess around with it. And another nice thing is that you can do it in a few different ways in Groovy. You don't have to use AST transformations. There's also a method called trampoline, which does exactly the same thing, but it works on closures, just like we've seen with .curry. Now, sometimes you have the people who are designated drivers going to the bar, right? They're not allowed to drink, or at least they shouldn't drink. That's your responsibility, not mine. So they end up drinking Cokes all night, correct? Now, if I'm a bartender and I have a refrigerator of Cokes, maybe you can think about it like a list of Cokes, okay? I'm not going to just take a bunch of Cokes and serve it immediately into the bar and, 100 Cokes, right? Every time someone requests a Coke, I'm going to grab a few, serve it. Grab a few, serve it, correct? And we can do that using a stream. We can take our Coke refrigerator and stream the Cokes out. This is a very nice open source library also directed for Groovy called Stream Groovy. It gives you all the streaming facilities which, if you're a Java programmer, you know from the later Java versions, or if it's native in your language that you use. So very similar to that. But this comes in a very nice library which is also adapted to Groovy and the Groovy syntax, or maybe the Groovy idioms, if you will. So you can take any list of objects or any iterable or any sort of source of data, and you can create a stream from it. And from that stream you can do all the typical operations you would normally do on a stream. So namely, in my analogy, I just have a stream of cokes. It can be 2 cokes, 3 cokes, it can be a TARDIS of cokes, I don't care how large it is. And I can take 2, or take as many as I want. Any basic stream handling functions are available here. And once I have the amount which I'm ready to handle, I want to handle, then I can use any closure on that amount. Now we have a lot of cocktails which are mixed drinks. We don't care about the order in which we mix a drink. Margarita being one of them. It doesn't really matter if I first pour the triple sec, then pour the lemonade. It doesn't really make a difference. In the end, I put it into the cup, mix it up, and pour it, right? And if you think about it, you can add it in any order you want, and it won't change the flavor. Now, it might remind you of monoids, which is binary operations. And Groovy makes it really easiest for us to define binary operations on types. I've changed things up here a bit. My ingredients are no longer anonymous closures. I've typed them, and I've created a cocktail ingredient type. And a cocktail ingredient is a collection of ingredients that is 0 or more ingredients. It can be nothing, it can be tequila and triple sec, it doesn't matter, they're all the same unit. But if I take an ordinary type, how do I make it associative? You can see that I've overridden here. Well, you can't see that I've overridden, but you can see I've declared a plus method in here. All binary operations in Groovy, plus, minus, divide, whatever, they can also all be overridden in the classes you create. That means I can take a class, such as this, declare a plus operation, which does whatever I want it to be done, and I can use it in the end, just like with the plus operator you can see here. Not only with the plus operator, but also with a plus method, which also appears in every sort of Groovy object. And that makes the types you declare super powerful. We'll soon see why. But here, what we did was compose ingredients, right? Every time you add an ingredient to another one, you combine the 2 ingredients, create a new instance of the type, and return it. So I've taken the 3 cocktail ingredients just as we saw before, and if I execute this statement, which takes the 3 ingredients in different order, it equals true. And it equals true because of 2 reasons. One, I've declared the plus, which makes this operator available on my type. 2, I've also used another very cool AST transformation, which already pre-implements for me equals and hash code, the identity part of the monoid. Very nice. Even nicer, there's a super excellent library called the gparse for Groovy, which gives us amazing concurrency utilities. And you can see in the same example of taking the 3 composable ingredients, in this case I've taken a list of ingredients and called sum. Remember, this sum is available because I've implemented the plus method, otherwise it would give me some weird object behavior. But also using gparse, I have an option to open a new thread pool, using with pool, and call some parallel. So it's like this really cool trick where you see the bartender opening the glass, taking 2 drinks and pouring this, or same thing, only it's the same thing. The important part of this is that the result of sum and parallel sum are still equal because of the attributes we've given the objects in the forms line. Now, every now and then, I have a cowboy come into the bar and he's like, "Oh, give me the strongest drink. I want to get really drunk tonight." So you say, "Okay, you might be a little dumb, but you give me money." And he wants an extra strong margarita. Now, you don't really have to mess around with extra strong margaritas. Why? We already know how to create a margarita, correct? All we need to do is add a double shot of something. Let's say we want to add a double shot of tequila. This doesn't change anything in the original margarita. It's a margarita, just as we saw before, with an extra shot of tequila. So how can we easily add a shot of tequila to a margarita? I can do it just as in the same example. I can take triple sec, lime juice plus margarita. But that's not very nice, is it? Because maybe I want to add tequila to any drink. You know, you want a screwdriver with tequila. That's gross, but okay, here's tequila. What I mean is I've created a general purpose closure, which adds tequila to any drink. And the syntax is a bit strange, isn't it? Because first we have the plus method, which we've seen before, but it has no target, right? I just call plus method on, who do I call it on? I can't see anything here, but I give it the extra tequila ingredient. And the other interesting part here is the with method. The with method is what lets me create this invocation with no target. With basically means take a closure and anything that happens in the closure, apply it on the target. In this case, I've taken the margarita, taken a closure which just adds tequila to anything, add it into the margarita. I could switch this out with any other type of ingredient and it would still add margarita into it. Now, this is a very powerful feature because anything can be executed in here, and you can also control the order of the invocation. What do I mean? In this default behavior, when you call the plus method, it will be called in margarita. But there are many other options. You can call it on the closure itself, which could be typed. You could call it on maybe a superclass. You can choose in Groovy the delegate of who the closure is invoked on, which is super powerful. And eventually, if I execute this, I'll get the same thing, but with a double shot of tequila. So, eventually everything ends up with monads, doesn't it, in functional talks. But unfortunately, I've looked into the monad example, and I don't really have time to get into this session specifically. But what I can recommend is if you check out this specific library. That's also a very nice library. And it gives you the behavior which you do want for monads, but in Groovy. Meaning you have, maybe you have just or nothing, you have either, and you have also, which I think is a very cool feature, if you use Java, you know that Java has a very specific way of handling errors. You have try catch finally, all those. And what this library gives you is also the infrastructure to deal in a monadic way with the try catch sort of paradigm of error handling, which is also very helpful when you have to write, code which either Groovyish or Java-ish. It's very, very helpful. So I also strongly suggest that you check this out as well. Now, I hope I managed to at least, pique your interest in regard to Groovy. I think it's a very nice language. I think it's very helpful. And even if you don't want to work with it in your day-to-day, if you do work with Jenkins, if you do work with Elasticsearch or Gradle, so just remember all what I've showed you here, because you can make even that scripting, set up small scripts, build your application, run your build, whatever. They can be functional as well. Just in time.
In the factor example, it's a question about the class. It gets a meaning only when you use it with the with, and then how, and there is, or everything has a class. Is that my question?
Yes, it gets the meaning only when you use with, but your target has to implement plus. Now, every Groovy object has a plus method. In my example, I've overridden it. If you don't implement plus, it'll be a bit hard to expect the outcome. You'll have to inspect whoever your class inherits from, or whoever your closure inherits from. It really depends on the situation.
But if it was another method that only certain types has, then the error will be only when you use the with, then you tell it doesn't have this method.
Yes, because you've got no target. In my example, the target was typed. I opened the closure and I'm given a type. And this can be used to avoid some mistakes in typing. But it doesn't really help you in the general manner of plus. If you have a specific method which only your class has, then typing the closure will really help, because you can use static checking to find out if you're wrong or not. But general methods like plus or minus, which every Groovy object has, it won't add to any safety. Yes?
In your opinion, where does Groovy stand out in terms of different functional languages available? What makes it outstanding for certain things in you?
It's a great question. I don't know if it stands out in anything special, because it provides the standard facilities partially native, such as the with method or the closures or the currying. And some of them, like the monads, come with libraries. So it doesn't have anything very special to it other than the syntactic sugar, which I personally like very much, and the fact that it's a scripting language which is used in very big tools today. So scripting for Jenkins, it's a lot nicer to do it functionally than not functionally. Okay, no more questions, then this is me.